So in the previous video, we have seen about regression. So now let us see about classification algorithm. Okay, so basically in classification algorithm, first we'll be seeing about logistic regression. So as we know, supervised learnings algorithms can be broadly classified into regression and classification algorithm. In regression, we have predicted the output for continuous values, but the prediction is not for the categorical. So we need classification algorithms for that. So again, a quick recap. So the classification algorithm is a supervised learning technique that is used to identify the category of new observation on the basis of the training data. In classification, a program learns from a given data set or observations, then classifies new observations into a number of classes or groups. Okay, so like the classes here, groups. Simple examples would be something like yes or no. Maybe you can create a 0 or 1. So maybe if you're going for image processing, you can categorize between a cat and a dog images. And maybe in mailing system, you can consider whether a mail is a spam or a not a spam. Okay. So classes can be called as targets, labels, or categories. Okay. So all these names will be interchangeable. So in sometimes I will be telling target, sometimes I will be telling labels, or sometimes I will be telling categories. So all mean one in the same. So unlike regression, the output variable of classification is just category, not a value. Okay, such as like it can be like kind of colors, green or blue. It can be fruit or animal, etc. Since classification algorithm is supervised learning technique, hence it is be labeled input data set, and which means it contains input which is corresponding to the outputs. Okay, so that is about classification, and the best example what I can tell is email spam detection. Okay, so that would be the best example. Again, with respect to classifiers, we have basic classifiers as I was telling, spam or not, and we have multi-class classifiers. So maybe you want to classify based on type of crop what you will be using. Okay, so classifying based on type of crop or type of musics. Okay, so that might be the other classifications. So I think that is more than sufficient introduction about classifications. So now we'll go with logistic regression. So basically, we have again in classification algorithms, we have logistic, and one more is support vector machines, which we'll be seeing in later videos. So those two are linear. We have non-linear, something like k nearest neighbors and naive bias, device tree classification. So those are now is non-linear. So again, the functionality of linearity will be seen with respect to um, the representation or the graphs itself. So let us start with logistic regression. So basically, logistic regression is a supervised learning again. So it is one of the most popular machine learning algorithms. It is used to predict a categorical dependent variable using a given data set of independent. So in this analytical approach, the dependent variables can be like finite or categorical. So maybe either A or B. So that is binary regression, or a range of finite options. So A, B, C, D. So that is multinomial regression. Again, we'll get to about the types later. Again, logistical regression predicts the output of the categorical dependent, right? So therefore, again, the outcomes can be categorical discrete values. So just like how I was telling earlier with respect to a classification itself, so it can be either 0 or 1, yes or no, true or false kind of outputs. But instead of giving exact value 0 or 1, it will be given the probabilistic value. Okay, so which will lie between 0 and 1. Okay, so it is not exactly 0 or exactly 1, but we can just approximate it and get the values if we are having only two binary regression. Okay, so logistic regression is similar to linear regression, except that how they used to be. Okay, so linear regression is used for solving regression problems, but whereas logistic regression is used to solve classification problems. Okay, so it is used in statistical software to understand the relationship between the dependent variables and one or more independent variables by estimating probabilities using a logistic equation. Okay, so basically this graph would give a lot of insights about the differences between linear regression and logistic regression. So in logistic regression, instead of fitting a regression line like a straight line what we can see over here, we fit a S shaped logistic function. Okay, so it is like a logarithmic function. Okay, so we are familiar with log, so it is like a logarithmic function which predicts values between 0 and 1. Okay, so basically here straight line is like predicting 0, 1, and it is going further, but here the curve line is always from the range of 0 and 1, so predicts where lies within it. Okay, so logistic regression is a significant machine learning algorithm because it has the ability to provide probabilities and classify new data using continuous and discrete data sets too. Okay, so logistic regression can be used to classify the observation using different types of data and can easily determine the most effective variable used for the classification. Okay, so here in the image we can consider maybe 2 points over here, maybe here y is equal to 8 or something like that. Sorry, 0.8. It lies between 0 and 1. So that is about little insights of a logistic regression. So how do we evaluate with respect to logistic regression? So in the previous one of the videos I had mentioned something known as we'll be getting the accuracy using confusion matrix. Okay, so the confusion matrix again with linear regression we had a straightforward formula which we used with respect to logistic regression. Here we will be doing is a confusion matrix. It's a very good way to look at the uh, correctively identified classes and misclassified classes. Okay, so basically the error or whatever is been not predicted accurately. Okay, so here with respect to the confusion matrix, it is a non-visualization. So we can do visualization too. Again, we will see that in projects, and using the values from there we need to find the accuracy. Okay, so using these values, so again in a minute we'll get to know what kind of values. So the formula for that is total number of correctively classified records divided by the total number of records. Okay, so that will just give us direct the accuracy. So maybe 9 out of 10 is predicted, 9 out of 10 is predicted correctively, so 9 out of 10 is correctively classified, and whereas one more is not done. So you can just do 9 divided by 10, so that is like 0.9, which is which has the accuracy of 90%. Okay, so a basic example. So again I hope everyone recalls this classes. Okay, so the reality and with respect to prediction, so here we have true class and predicted class. So again true positive, true negative are the correct ones. Okay, so those are the correct ones, so that's why it is highlighted in green. Okay, so where it should be positive and it is predicted as positive, and in true class also it is positive, so that is true positive. And false positive again as I had mentioned before, like we had already seen this, right? So false positive where a positive is predicted as sorry, a negative is predicted as positive. Okay, so that is false positive. Okay, a negative is predicted as positive, and false negative, so basically here it is like just opposite. So basically we are predicting positive value as negative, so that lies in this category. And with respect to again the last one, true negative, so again it is correct. So this you will get in terms of a matrix form, so that's why it is known as confusion matrix. So the matrix here would have like two rows and two columns if you are talking about only two um, or by regression. So only binary regression, only two outcomes. So at that scenario you will have values written over here which are true for being positive or negative, and false for being positive or negative will be written over here. Again with respect to the projects, you will be understanding again it is straightforward output itself, it is not anything else. So it is just the confusion matrix which will be created. So like this prediction will be done after predicting our test data set. Okay, and comparing with the actual output. So then we'll be getting this. Okay, so again working on a logistic problem will give more insights what exactly is the confusion matrix to see the output. Okay, so this is how we evaluate a logistic regression. And again we have few more things about logistic regression. So one more thing is stratified sampling. So where a class is imbalanced, it's best used to like where the class is imbalanced, it is best to use stratified sampling. So this makes sure the test data set and training data sets has equal distribution in the class proportions. So what exactly it means is we'll see with an example. So just consider we have a total number of classes, so 0 to 100. Excuse me. So that will be something like 0 to 100 and 1 to 50. Okay, so the training data set, and you can consider test data set as 20% of it. So 0 as 20 and 1 as you can consider number of boys and number of girls. Okay, so 0 for boys being 100 and girls 1 being 50. And here considering the test data set should be 20% of it itself. Okay, so again 100 for 100 the 20% is 20 itself, and for 50 it is 20% is 10. Okay, so basically, if at all you are having more number over here as like added plus 150, plus 50 or plus 50, so 150 and 100. So at that time it should be again 20% itself. So 150, 20% would somewhere around come like 30, and for 100 again 20% is 20. Okay, so we should have equal distribution. So that is the stratified sampling. Like with respect to here, we have two different cases, right? So again, here we can consider two classes. Okay, so we have two classifications. Okay, one being boys and one being girls. So you can get two data sets also. Okay, so this might be in a separate data set and this might be a separate data set. So when you combine this and randomly take 20%, so it will be 20% of the whole. Okay, so instead of taking 20% of the whole, we need to take 20% of individual classes. So again, if at all we deal with uh, maybe multi data sets. So before combining, we'll split the data set and training set, and then we'll be doing our whatever. Sorry, we'll be doing a test data set and training data set for individual data sets. Okay, so 20% for this one and 20% for this one. We'll be splitting, and then we'll be combining instead of combining at the very beginning itself. So we will concatenate it at the beginning and then divide by 20%. Rather, we'll be going with this. So here, if you are going with combination one, then it will be like 20% would be randomly selected. It's not like the first 20% will be selected. Okay, so the first 20% out of 100, if it is, then it is 20. So it is not like that. Those 20 will be selected, but rather it will be selected in random. Okay. So when it is selected random, we won't be having the equal distribution between these two classes. So this is an I stretch on this slide because it is very important, because this will have a huge impact on your accuracy. Okay, at the end result where you are seeing in confusion matrix or with respect to visualization of data or checking with respect to accuracy score, definitely it will have a huge impact with respect to your predictions. So for a very good training of a model, so we have to have equal distributions. Okay, so this will be the best approach what we can do. Okay, and again we have few types of logistic regression. So I was mentioning binomial and multinomial at the definition itself. So in binomial logistic regression, there will be only two possible cases. So those are dependent variables, two types of dependent variables, such as 0, 1, pass or fail, true or false, yes or no. And I have many examples. And when it comes to multinomial, this one, so there can be three or more, which are actually unordered. Okay, so they are not ordered in any way. So here we have example as like cat, dog, or sheep. So these are kind of, we are not ordering them. Maybe if you're considering alphabetically, you can order them, but with respect to the animals, we won't be able to order them. Okay, so again the order again, if you want to order, you need to take an external parameter like alphabetic order or size of the animal or something like that. Okay, when it comes to images, okay, image processing, you want to create where you will be predicting whether it's an image of a cat, dog, or any other animal. So at that scenario, it won't be ordered. And next we have ordinal, sorry, not ordinary, ordinal logistic regression. So there can be again three or more possible cases in this type, but it will be ordered. Okay, so basically here you have low, medium, high. So you can the name only it is telling, it is classifying with respect to lower, medium, high. Okay, so something like that. So that is with respect to logistic regression. So that is the first classification which we are seeing. In the next session, we'll be seeing more classifications. Okay, so I just forgot to just add the assumption. So uh, here basically we have two assumptions. We had four in with respect to linear regression. So logistic regression, the dependent variable must be categorical in nature. So else they will come under regression. Okay, it's not in terms of classification. So that is the first thing. And second thing is the independent variable should not have multi collinearity. Okay, so it should not have multiple collinearity property. Okay, so again with respect to examples, you will be understanding better. So that's all about logistic regression.